Hello, everyone, and welcome. It's my absolute pleasure to be here with you today and to share knowledge. And this is what it's all about. Um, a little bit of funny of the beginning of the presentation. There is a little bit of story behind the pictures. So it kind of started as a small challenge, and then it kind of grew when more and more people started doing it. And I think the first one who did this was Wendy. You might have seen her in one of the track. Um, but yeah, it was really funny. Let's do something different instead of replacing the the guy down there. Um, I decided to scream security back at DevOps, and that's the whole purpose of the talk today. Well, actually, a nice fireside conversation rather than a scream. But we start powerful, and then we go along. Um, the talk today is more or less about a conversation on how an application security program evolves, and a little bit of stories and hint and tips that I can give you guys, and also reference and information that I wish when I started on application security I could have, so that I could fast track my application security program and the work that we did in few the work that I did in few organizations. So sometimes we forget that application security is really driven by people, and we tend to focus a lot on technology and technology to solve problem, but ultimately we leave behind the management team, the business owner that effectively own the risk. And I always say that application security is such a people uh, it's such a people transformation, because you tend to bring the whole organization along to fix vulnerabilities, and vulnerabilities are nothing different than actually fixes of bugs and other stuff. So it's just that because they have the label security on top of it, they tend to be seen as different, but really they are not. So it's around the methodology of how to manage risk of your software. So as I said, we can explore a little bit the driver that driven the creation of Security Phoenix as a program of work, and then the tool set behind, and the reference and other information that we got through. But if you look at the real meat of the talk, we're gonna see effectively how the people, the trust, the KCI, the metrics that we use in the program were actually used. And no one company, there is no one size that fit all. So fundamentally, just take this with a pinch of salt and apply to your use case, and try and try and try in the best of the DevOps or DevSecOps methodology. Try again and see what works with your people, your team. And that's the whole philosophy. So a little bit about me. I'm very passionate about application security. I have a podcast, and I've been doing talks about application security for quite a while now. Last one actually in presence was actually at Upsec Cali, about the previous iteration of Phoenix. So I've been helping different organizations on application security, cloud security, and I'm currently chair of the Cloud Security Alliance UK and founder of a couple of organizations. But today is really to share the stories and the background and the knowledge behind the program of work and the tools that we created to fix effective and to fast track, um, to bring the technology closer to the people aspect of an application security. And one mantra that you're going to hear me over and over say over and over and over is that security is everybody's job. But as security people, we need to make security engaging, frictionless, easy, if you want, in a way. And that's why application security Phoenix is also called AppSec Easy. In a way, because application security tend to be really, really complicated, and sometimes why. So a little bit, as I said, what do I talk about? Well, application security. I tend to be a nightmarish job, because as soon as you fix something, well, other 400 bugs appears. And that's the nature of things. But we come with high spirit. And then cloud security. And I think more and more the two words are really coming together, because everything is becoming code, everything is becoming connected. So we almost, with serverless specifically, we end up losing effectively all the infrastructure and all the complication of setting up a stack, and really owning effectively codes and code deployed somewhere. And ultimately, application security and cloud security are the only two components that remains for us. And DevSecOps is exactly the representation of what I love about this work, because everything becomes a pipeline, everything becomes code. So it doesn't matter what problem it is. With DevSecOps and a good collaboration between security people, developer, and operation and cloud operation, we can solve this. We can crack this. So I want to give you guys a little bit of history behind the driver, the major driver, and why the application security tend to be such a problem. So the first problem is effectively what drives the motivation behind applying security in anything. So why would you apply security? Well, because fundamentally we all get affected if something goes wrong. Tell me if you had an account in any of these organizations, and the list keeps on growing and growing and growing. Um, Fundamentally, application security are responsible almost 40%, roughly 40% of fixes or bugs um, of those breaches. And you see the size and the impact, and some of those are actually having much bigger impact than other, like Equifax or other uh, data breaches that involve really personal information. And the main two categories that I tend to describe of people that are interested in doing breaches are fundamentally activists. So people that want to do this for a cause. And maybe the majority of it, and the one that are more quiet, are the financially organized or financially motivated hackers. So, or actually, I want to stop calling it hackers. I'm gonna call. I'm gonna refer to them as criminals. So, criminals that are financially motivated and they have no refrain or restraint. And a major challenge that we have in security is that security vulnerability keeps on popping, because uh, the nature of code and the speed that we have right now is enormous. I mean, if you just take Tesla, Tesla is a super complicated software, and it's just a car. So the more line of code, the more chances of security threats, and we are fundamentally constrained, because as security people, we can't look at every single line of code. So we need to scale, and we need to scale fast. And we need to scale fast with technology, but also with the people that's going to help us. Because with technology, we can address the problem at the very beginning of they usually know a shift left. So the sooner you identify a problem, the less dependency that problem has, the quicker you can resolve it, and the more cost effectively you can resolve it. The closer you can get to the ID or close to the developer environment that enables you to identify quickly. If you need to go back a week on the code, I don't know about you, but I don't remember what I ate yesterday. Not even to say what I coded last week, or what are the rationale behind that variable name of VVVW something something something. It's quite hard. So the sooner we can identify a problem, the better it gets. And from that reason, it came the creation of a framework, a methodology, and then a set of tools, and that is called an application security program called Security Phoenix. So we focus on few pillars, and we're not going to explore them all, because otherwise we're going to be here all day. Not that I have a mind, because I love to share knowledge, but probably I'm going to kill you with information. So the application security program is fundamentally secure by design, build and test, and security in the build and test, operational security, governance and risk management, and people and education. And today we probably fix on people and education and the people aspect, and build and test. So I want to explore this very, very quickly on how do you define evolution? How do you get better? I tend to say, well, you need the framework to measure it, and I kind of created this kind of block measure of different areas, and this is actually based on BSIM and SAM, and on the governance around it, and well structured framework to actually do that. And but aside from BSIM and SAM, we found that having a list of actions that you can identify and see if you're getting better or worse it's really, really easy for teams saying we're at this stage of, for example, build and test or secure by design or governance and stuff like that. So it's just another way to cut, but it's fundamentally a tool to say we're here, we want to be there as overall as an organization, and that enables you also to budget effectively a security program, because with this information you can drive KCI or metrics, and you can say we're here, we're bad, we want to be slightly better tomorrow, in a week we're going to be slightly even better, and so on and so forth. So this enables you and everybody else to drive. And the reason for the majority of the of the work and the output of effective of that series of framework and questionnaire was the major problem that we identify is traceability. So it's traceability between application being deployed, built, and the source code that you originated them from, libraries that you originated them from. And most of the time, especially in big organization, you don't have the traceability, or you don't have um, enumeration or knowledge of what you have in production, and even less in production if you have your own application, where they come from and who was the team that built it. And I kind of refer to that as walking in a room blindfolded, and there is glass all over the floor, and you can hear that there is a problem, but you can't feel the extent of the problem. So unless you shine the light and effectively you do enumeration and software composition, um, or even enumeration and that's it, knowing what you have in production. And on cloud, this is really, really easy. But to know which element do you have deployed where. But from an application perspective, tracing the code and the application and how they are composed is a really, really hard problem, because you have different elements that compose an application. It could be an API, it could be a website, it could be the stack, it could be the containers, it could be the piece of code that deployed the various part, the microservice, and so on and so forth. You don't really have a good representation of this is my application, this is how it is composed, and this is the risk level. And that's the kind of struggle that we had, I had from the very beginning, saying, well, I don't know how the application are actually composed. And how can I say an application is good or bad, or a piece of code is good or bad? And overall, how much is the impact? Because from a business perspective, businesses used to discuss about applications. This application does this and generate this amount of money. It doesn't say this microservice does this. Or if you go to the board and you tend to have that discussion, they look at you, it's like, what? A micro what? And unfortunately, that's a state where we are. So we need to abstract. And I keep on repeating the traceability problem because it was one of the hardest things that we encountered during the work, and several iteration of the work. And I kind of also describe it as is baking cake. You need to have the ingredient of the cake if you want to know if some of the component is actually gone bad, so that you know how to fix the cake while baking it, or actually in post production when it's on the shelf that it's maybe not good anymore. So we started attacking the problem on enumeration, but enumeration was a really hard problem, and so we needed some quick win, and we needed some um, methodology. And we look at the methodology of the deployment of the traditional deployment of security in an organization. And usually it's very serial, it's very gated process, where if you're lucky, you have all the step. If you're unlucky, you probably have just the operational security with just a pen test at the very end. So if you're very lucky, you have people that describe your non-functional requirements. So what do you need from a security perspective? The testing methodology that you need, and maybe you have some automated testing like code scanning or library check. And then all the way down to operational security, where you have maybe some control that scan if you have patches available or if everything is fine. And we said, well, we need to modify that, because it can't be that you design something, then you send it to somebody else to see if it's right or not, and then it's a gated process, and then you need to wait a week, because it can't work like that. Maybe at the beginning, but not ongoing. So you start facing the struggle of which project do you select, which are the most project that you want to get involved in at the very beginning, so in the design stage. And then how you can scale effectively in the testing stage, and how you can give effectively that control or delegate that control to the development team. How can you enable metrics, and how can you give guidance and guardrail effectively to the team to do their job and say, well, this is good, this is bad. So this kind of vulnerability you need to fix, or you need to be under this threshold of, I don't know, critical or high or low. Those are the things that actually enable the process to be, instead of a gated process, in parallel. And you can always have breaks in the pipeline when you say, well, you went above or below that threshold, but that's not really helpful, because it should be the least things that you do when you break a build, and there are only a certain amount of time that you can do before somebody else say, well, not anymore, enough, unless you have really a strong commitment from a security perspective. So we're going to focus really on the build and test. Otherwise, in the design part, we can talk to endless. And we kind of came to the level down of effectively the number of tool, technology, methodology, to take to the second level from a security perspective. And you don't have to do them all. This is a reference framework, and we actually wrote a paper on it with a lot of people in the industry to describe the various pieces and what you could do and you couldn't. So I'll be happy to share it, and actually it's at the end of the presentation so that you can refer to it. But I want to shine a light of the various components, and then saying which is actually the one that is going to make the most impact or effect to you. And you see on the left, you still have the composition. You can achieve that slowly but surely with methodology like we're going to explore later. But really is the whole process of that we are exploring is called vulnerability management. And a vulnerability assessment is when you do that. You do an assessment or you check something a point in time. Like you go to a doctor, it checks you, and you say you're good, and then you walk there and you start sneezing. You say, and then the next day you're sick. And then if you have a doctor that continuously checks you, it say it can catch the virus at the very beginning. And I don't want to talk about virus because I think we had enough of virus and vaccine. But just to get you an idea, it's a life cycle period. It's a life cycle moment. So it's kind of a wheel that goes around, and start with the discovery, then triaging, and prioritizing effectively what to fix. Because I'll tell you what, at the beginning when you do this, you're gonna get overwhelmed, and then deciding what to do and what to fix and what's more important. And we're gonna explore in a second what and how to prioritize and how to integrate with the various tools. But the methodology that we created for this is called the ABC and ND of application security. So identify, detection, visualize, and respond effectively. Identify what your problem is, detect it ongoing with security scanner, visualize it with tools and technologies, and then respond and recover. And to do so, we created kind of an application that is called the Security Phoenix, together with a methodology that kind of takes all the feed from the majority of tools that you have in the market, and probably next year we'll integrate more also the open source stuff, and it aggregates in those virtual view. And you can see on the top on the bottom right, it's focused on application, because that's the kind of language and terminology that the board want to use. We're going to see later on that we go dive in all the way down to the technology, so that the tool that developer can use on a day in, day out. And then we said is a people problem. So how do you link effective an application to people? So one of the experiment, and the one that was probably most effective, is any kind of large organization have a kind of mapping of an application and people that maintains that application, or at least one application owner, or somebody that maintains a repository. And then you have, on the other hand, the scan an application, scan a repository. So you don't have a match between an application and a repository and the people. So you have these three triangles of things. So you could potentially get into Git, effectively download the list of maintainers, pivot on the email address, and then get to the application owner, and then hence to the application, and start tracing that dynamically The best way to do this, this could be the initial assessment. The best way to do and achieve this is actually to maintain a YAML file or something similar to trace the application and the code ongoing. And that's to solve effectively at scale the asset problem. And then from a scanning perspective, you can um, do it's effectively trying to multiply your security team to get it as close as possible to the developer, and is a way to scale. And again, we can potentially aggregate, but the best way we found is to link the scanner result and to aggregate on a various risk dial. So it gets a gauge. The board or your CISO will get a gauge of effectively the risk level of the organization as a whole, divided per topology of risk and per application. And in the right, you have an application composition divided with different blocks so that you can immediately see where is the risk and what is the impact of the various components. And then you can dive in the various components and you can see effectively the risk of the various stuff or the various components. So you can see which is the application with the majority of risk, and then you break it down in different components. And that application composition is really key to decide on what to prioritize and what is exposed. um, And again, it's all about visualizing and deciding what to prioritize first, especially at scale, especially when you have a lot of application or a lot of vulnerabilities. In this particular case, you have timeline and high, medium, and low. So, as a very simplistic way, you can say, well, if you are beneath that threshold consistently, then you're good. Then you can just deploy in production. And as long as you maintain that level, then we're very happy with. And then the whole triaging, that is fundamentally a process of um, evaluating the vulnerability, again, vulnerability management. But I want to stress the fact that the whole program was based on creating that level of trust. So we introduced the level of threshold. So how do you maintain, how do you delegate, and how do you keep that trust model to your development team? Well, maintaining um, maintaining a list of people that were doing training, maintaining a good, healthy balance between the stuff that we build and stuff that we fix. Like it could have been, um, you can get it that from Jira or from other tool. We build it inside our tool, but the key things is we started describing what you build and what you fix, and most importantly, giving the targets. If you meet all these three parameters, 1, 2, or 3, then you get a license to operate. Then you don't need to break a build because we trust your team that even if one day you have more vulnerability, you're going to fix them tomorrow. So I want to start closing with the education and the various reference, and I'm going to go quickly through them, but everybody can have the presentation afterwards. So there is a tons of links and reference. Um, but the key things is use awareness for your users. So they're going to start asking you the right question of why there isn't multi-factor. Your business user will start putting security requirement inside the business requirement. Um, Look at this result of the scanners for each people. And we build some dashboard and some view actually for people and looking at people and the major issue that the team had so that we can effectively doing training. We were doing training on the job for the teams. And then that was delivering with a very short 30 minutes, maybe sessions on the job, hands-on for a lot of team, a really good education. And that's how we can scale, because effectively you start instilling and injecting security in everybody, and then make training entertaining. So there is a lot of stuff out there like OS Juice Shop, to or Zap, Webgoat, where you can actually uh, give something to your team to play with and start learning effective vulnerability. Or cheat sheet could be a very quick way. And this is a lot of information, I know, but this is something freely available. And between the lower end is conference and people and things that I follow and like, and where I learn a lot. And on top, you have tools that you have and that I follow. This is the report that I was mentioning before, and it's freely available for everybody and explore much more in depth all that we discussed today. Another couple of things is application security or hashtag mentoring Monday or cyber mentoring Monday now. Um, it's a hashtag that me, Tanya, and other application security people claimed use it and monitor it. So if you have a question, do that. And this is my list of arsenal. I'm going to have an article coming out probably at the end of the month or then the next month where I discuss effectively all the open source tool and how can you avoid paying maybe for an expensive scanner if you don't have to. They don't deliver the super best result, but it's a very good start. And I want to close with security keeps on being everybody's job. So it's about bringing security people as close as possible to the developer and helping the developer to get better and better. So to recap, measure and define where you want to go. The key metrics, trust developer, give time. And the only way to give time is working with your management team. Application to code and library and traceability, those are super fundamental things. And vulnerability management as part of our everyday process. Fixing something is not a point in time. It's continuous integration and continuous security. Application security is complicated, simplified, and do education based on data. And with this, I want to thank you. Those are my contacts. If you take a snapshot, you can see effectively my contacts, and you can get in touch with me on social media or LinkedIn. I have a podcast where I talk a lot and extensively about application security. So feel free to have a listen to, and I'll open the floor to the questions because no right presentation is. But if you don't have any question, I'll be on the Slack. So thank you everybody for listening and stay safe and do secure code. See ya.